Hello and good morning, everybody. It is Monday, September the 14th, and I just got a punch out in the mail, and I got it all hooked up on the bench here, and we're gonna be starting this guy today. So I've got it all hooked up. It's actually a decent looking board set. It's pretty nice looking. It's not all corroded or nothing like that, so it'll be nice to work on. One that's not a mess. So I'm going to go ahead and I've got it all hooked up. I'm going to go ahead and turn it on. Okay, it's switched on. And I don't know if you can see that or not. It's just got some random garbage going on. There's nothing going on there at all. So, and what I think I'll do is I'll put this up on the stand. And I'm going to switch to the top monitor, see if it's got anything going on. And this is the top monitor. So it is doing nothing. Go back down to the bottom monitor. Okay, so that's what we're starting with. A whole lot of nothing. So, get this back out of here. I think what we'll have to do is flip this guy over and start messing around with the CPU board. Because it looks like we have a CPU board issue, first and foremost. So, let's look at that. Okay, I'm going to let you look at the oscilloscope while I probe around on the CPU. I'm just checking CPU signals, reset line, all that, clock signals and everything like that. So reset is 26. 1, 2, 3, 4, 5, 6. So we are high all the time on reset. There's no reset. NMI comes off of a flip-flop on 17. Here's 17. There's nothing going on there. It's just high. Bus acknowledge is 23. 1, 2, 3. And that's always high. Bus request is 25. I already looked at that. Reset. Read and write are 21, 22. Here's 21. Here's 22. They're both high. Clock is on pin 6. 1, 2, 3, 4, 5, 6. Here's my clock signal. Always high. That's not going to cut it. So I want to check the beginning of my clock signal off of the 8 megahertz crystal, which is right here. And 6E is an inverter that is used with the clock circuit. And that is this guy right here, I believe. Yeah. Okay, 6E. Looks like. Up to 10. Right there's 8 megahertz off the crystal. What is going on here? Oh shit, this crystal's broke. That's what it is, this crystal's broken. The 8 megahertz crystal's broke. So we'll come down here, I'll show you. That guy right there. That guy's broken. So I'm going to have to replace that guy. Well, I have a Popeye board here that has no ROMs in it or nothing like that. It's my friend Todd's. It needs to be repaired, but it's the only thing that I can find that has an 8 megahertz crystal on it. So I'm going to use the 8 megahertz crystal off of this, and then I'll have to replace that, of course. But I'm going to use that to put onto that guy right there. That's that punch-out board. And we'll get the 8 megahertz clock working on that thing. And then I'll put this back, and eventually I'll have to replace this crystal on this Popeye board. But, yep, I'm going to use this guy to save that guy for now. Okay, I have replaced the 8 megahertz crystal, and I've hooked it back up and turned it on. And we're getting somewhere. There's too much blue in the monitor, but that's okay. But it is not right, as you will see. I'm going to go ahead and put the camera up here so that I can show you what this thing's doing. You'll see the character guy, the green guy, is way in the wrong position. He's up too far. And if I go to the top monitor, I'll show you the top monitor. You can see the top monitor is goofed up. Yeah, there's not much going on there. But you will see at the punch-out splash screen that the you'll see right here, it's the circuitry that allows that to go through is working. You know, the colors are way wrong, and that could just be a selection problem. The back PCB has issues. You know, that's for certain. So this is the video, the video board, the big video board makes that splash screen, and it just goes, it passes through both monitors. And that little guy holding the belt, I believe, is made on the video board too. So that stuff is being made. The only problem it looks like with the video board is that your green grid guy is too high. So we're going to check some positioning circuitry for that guy. It looks like my CPU board is probably good, working good. Preliminary. There's DMA stuff that is made on there. I'm going to put the fluke on this thing and see if I can read to all the video RAMs and the video RAM on the back PCB that the CPU talks to. So I want to make sure that all of that is okay, type of stuff, and go from there. So let's do that. I'm gonna go ahead and hook the fluke up and see what we can talk to and what we can't. Okay, something very interesting. I have the fluke running the board right now, and I'm on the top monitor, and you'll see the top monitor looks a lot better. We still have color issues, and we're missing some data. You know, we're missing the picture of the guy and that kind of stuff, but it looks a lot better. And the only thing I did was this non-volatile RAM right here, C000 to C3FF, is, I believe, this chip right here, which I've completely socketed and removed. If I was, let me show you what I was getting. I'll do a RAM short at C000 to C3FF. Okay, and of course it's no good. I'm just going to loop it and see how it's giving me that. This is only 4 bits, so if I put a good chip in there, it should say bits F0. So I am going to try popping a chip in there. 2114. Okay, and it's still saying F0 or FF. Yeah, I don't know. Let's run this thing. Okay. Same thing. Color issues. Artifacts in here. Alright, back to the drawing board. I'm just going to keep messing around. Everything else checked out good, so we'll just keep messing around here. Okay, first things first is I am going to work on I'm going to work on getting Glass Joe in the right spot on the video board. Remember how he was kind of floating up in the air and punching nothing? So my first order of business is I want to not worry about the back PCB just yet. I want to work on getting Glass Joe in the right spot. Yeah, I got a little bit of flashing positioning problems with Glass Joe as well. That's new. And a lot of these chips right here are not right. And a lot of them just don't look very good at all. First thing I'm going to do is I'm going to put the proper chips in these sockets and see what we get. So I'm going to shut it off. And I'm going to remove these guys. It's got LS parts and for the most part. And I'll probably end up having to just remove these sockets because they're not good. These are F series, that's correct. This 163 has soldered legs on it. And it's an S163, it's not even a fast F163. Somebody put S as in Sam series chips. And they have to be F as in Frank. So I'm going to go ahead and grab those. And they had 163s in there instead of 161s. I'm not sure if they get a reset or a clear pulse or not. But these are F series, as it's supposed to be. 161s. Okay. And F283s. Okay. Make sure all the notches are in the right way. Okay, I'm going to start this thing back up now. Okay, now we got Glass Joe has kind of disappeared now. And like I suspected. Yeah, Glass Joe's kind of all over the place now. Okay. Nice. Now Glass Joe's kind of disappeared. When you're probing these, you want to probe the socket and not the chip on the outputs. Those were there. Yeah, see now here's okay, never mind. Okay. Good old Glass Joe. He was flaking out, now he's just flat out disappeared. And I don't think it, well now see he's come back now. He's in and out. Okay. So we're going to have to, let me put this stuff up. Okay, and I'm going to need the video schematic. This is all component stuff. Okie doke. Yeah, I'll be honest with you. The way that that looked right there, the punch-out thing was like over on the side and all goofy. I think I'm going to have to stop and solder these chips right into the board. It's just, every time I work on a punch-out board, I have the same problem. Where they just, it won't work with these sockets. So I'm going to do that. I'm going to shut it off. I'm going to do that really quick, and then I'll be back. Okay, so I have eliminated these sockets for the F-Series parts, and I got them soldered right into the board to eliminate any kind of flakiness there. But I am still, this is kind of jittery. This is all good. It's just Glass Joe, the Glass Joe circuitry. The opponent circuitry is a little flaky, and there's flakiness on the player as well because he's sitting up too high. But we've eliminated some variables. We've eliminated those sockets from the mix. So now we can move on. On this board here, this is still jacked up. If I take this and try to maneuver this over to this guy, you will see the top monitor is still jacked up. But right now I don't care about that. Right now I just want to work on this board right here and get this one, get all the sprites, get them all in the right working order, how they're supposed to be. And then we'll move on to this board and we'll deal with this issue. The punch out, that's the video board. The video board's a little flaky. Yeah, I think what I'm going to do is I'm going to let this thing just run and run and run. And I think it'll get flakier and flakier as it goes. But I'm going to start probing around some on here, and if I find something a little weird, I will come back to you. Okay, I think I found the first part of the mystery with the green player being weird. Down here, this latch right here, you can see it gets an enable pulse on pin 11. Output control is always grounded, so it's always should be outputting. And it's just a latch which on the rising edge of this clock pulse will latch the data to the output. And so I'll take you and we'll kind of look at that. It's this guy right here. There's your enable pulse on pin 11. See it? Okay. Right here is an input, and its output is right here. Just a floating mess. So this is an output, input, input, output, output, input, input, output. Yeah, see, it's really strange. Anyway, that guy right there needs to be replaced. And I bet you that will fix the green grid guy. So let me go ahead and take this thing. You know what I think I'm going to do is I'm just going to mark that with a red dot, and then I'm going to continue on. I'm going to move up to the other, the opponent, and start probing around the opponent. Be right back. Okay, here's the new chip right there. $373. Here's the old guy. Fujitsu, of course. And that did indeed fix our green grid guy. So that's one problem taken care of. Now we gotta look at what's making Glass Joe flake out. And this. It's on this back PCB. Not on the back, it's on the video board. It's on this video board, but it's in the opponent circuitry. So that's next. We'll find that one next. Okay, I got the game going right now. It's looking pretty solid. A little flake here and there maybe. Nowhere near as bad as it was. I was probing this 367 right here. And every punch-out board I ever look at, this 367 sucks. I'm going to remove this 367 and see what this thing does. See if Glass Joe's jumping all over the place again. Yep. Sure is. Every one of these that I look at on every punch-out board looks like crap. I think every time I've done a punch-out repair, I've replaced this chip. Okay. Let me see. Okay. And this is a straight buffer. It's always enabled. This is an input, and here's its output. Look how crappy that looks. And over here is an input, and its output is right here. Look at that. I'm going to take this guy right here and put him back on here. Alright, I can't see what I'm doing. I gotta put my glasses on. And I've got it back over. Let's see if it's straightened out at all. By golly, I believe that's it. I'm going to look that chip up on the schematic and see what exactly its job is, what it's driving. So let me check that out and I'll be back. Okay, and we are back together. New chip right here, 367. And here's the old one. Fujitsu. And you see over here, there's no flakage. more flaking out. So now I believe it's safe to say we can move on to the back PCB. Uh-oh, I see flakage. Or did I? I'm going to let this run for a while and just kind of monitor it. I'm not sure if I saw something flaky or not. It doesn't look flaky at all here. Looks perfect. Nope, I saw some flake in there. Yeah, there's something still a little goofy, but I fixed most of it with that chip. I'm gonna, like I said, I'm gonna look at the schematic and find out what that 367 drives, because I think whatever is correlating to the circuitry that is driving is what is causing this flake out. I think. So I'm going to check into that. I'll let you know if I find anything screwy. Alright, I was doing a little thinking, and I recently did a punch-out PCB repair. And if you remember, it had a bad counter in the DMA circuit on the CPU board. And if you and I went back and I looked at that video because I jumped a good 161 over the bad chip, and the board came back to life. And what I saw was Glass Joe would come all the way over to the corner of the screen, right in this area right here, like I was seeing. I'm getting no flakage now in my sprite circuitry. You know, remember how it was kind of flaky where he would jump around a little bit, and every now and again he'd come over here in this corner and they'd like stick there. But I haven't seen that in a while. What I think I'm going to do is I'm going to replace all of the 161 counters in the DMA circuitry on the CPU board, because I think I have a flaky one, but it's not always flaky. As you can see right now, it's perfect. There's absolutely no flaking going on. But if you remember, there was flakage, clearly, where Glass Joe would kind of, you know, jump over here and stuff and zoom bigger and just kind of flaky a little bit. But it hasn't been doing it at all lately. So what I think I'm going to do is I'm just going to replace the DMA counters on the CPU board, because that is something that I think could have been causing that flakage, and I want to replace those because I don't trust them long term at this point. So I'm going to go ahead and replace those DMA counters and make sure that this is solid. Because right now it's impossible to fix something right now that looks like this, because it doesn't look, I mean, yeah, we've got color palette problems big time, but that's not a big deal. But this little flakiness, that's impossible to fix, because right now it ain't bad. So I think what the problem is some of those 161s, or one of them, is just kind of flaky at times, and it'll make Glass Joe do weird things. So in order to shore this up long term, I'm just going to replace the DMA counters. Every one of them. There's 4 on the CPU board. I'm just going to go ahead and replace all of them. Okay, now that work is done. It's this chip, this one, and this one. Those 4 161 counters make up the DMA addressing. So those are new. So that is not going to be a problem anymore. If I see that flakage, then it's actually going to be something either in the timing, the clocking, or the or something on the other board, the video board. So just gotta, when you see them little flakes like that and then they go away instead of getting worse, it's like, what do you do, you know? So we'll just renew the whole DMA, that direct mode addressing type stuff, and that's all we can do. So anyway, I'm going to go ahead and put it back together, and we're going to start working on the back PCB. Okay, so we are all back together again, and looking good. We know our DMA is rock solid now, and will be for probably the rest of this board's life. Yeah, that looks good. I'm going to call that perfect now. We know our DMA is operating as it should. So now we're going to just move on to the back PCB. You see Glass Joe's gloves are like pink. The color palette is not, it's just not right. I'm actually going to test these PROMs, I believe, in my reader and make sure they are correct. But anyway, we got bigger fish to fry anyway. I mean, I'll cut away and then come back and show you what the top monitor looks like. And here is our top monitor. You can see the bottom monitor stuff is coming through good. The colors are completely wrong. But when the punch-out screen comes through, you can clearly see the punch-out splash screen. So that circuitry is working that allows that punch-out splash screen to come through on both monitors at the same time. So that's working good. It's just this top monitor with its logic. It's the background, what it displays with the player and the opponent and the power bar and all that stuff is non-existent. So and the first thing I'm going to start probing around is probably the 367 buffer. See, here's that screen that comes through good, so you know that circuitry is working that allows that video board, that's made on the video board right there, and that just allows it to pass through to the top monitor. Yeah, I think I see that guy glitching. I'm going to switch back to the bottom monitor. Okay, I was doing a little thinking, looking at the schematic a little bit with this back PCB, and I know that when I had my Fluke hooked up to this, I could read and write, do RAM checks on the RAM that's back here on the back PCB, no problem. So the problem is not in the right side. The problem is the read side of these RAMs, the hardware reading the data out of these RAMs and pumping it to where it needs to go. That's where the problem is. So when I get back to this, that's what I'm going to start looking at, is really looking at the schematic, looking at the read side of the RAM data. It has to address these ROMs properly, and then make its way over to these color PROMs and get pushed out to the screen. So that's what I'm going to concentrate on, is the read side of things on this PCB. Okay, I am going through with my logic analyzer and just analyzing the beginning of things. These guys, these buffers right here on the back PCB, and I'm looking at 2K right now, and I've done all three of them, all the other three, and they were perfect. This one, however, is not. This one's not right. You can see what it is the highest bit is stuck high over here, right? This is actually only 6 bits, so it's it's one of the bits anyway, equates to this. If you see, the highest bit here is in this F. This is what it's supposed to be. This is what's coming in. This is the out. You see, in, out. And enable, it's enabled low. This whole time this is enabled. And right here it's 27, but down here it says 2F. Well, what's 7 in binary? 7 in binary is 0, 1, 1, 1. But it's coming up with an F, which is 1, 1, 1, 1. See, this highest bit here is stuck high. Now I'm only analyzing 6 bits because it's a 6-bit part. So this fourth bit of the 6 bits is the one that is stuck high. Yeah, see? Yeah. The most it'll ever be is 20 something, because this is the high side. The 2 bits, I'm confusing myself. Anyway, you'll see here it's stuck high, it's F. Same here. Right here, 2 is 0010, but the highest bit is stuck high, so it's 1010, which is A. I'm sorry about the glare. There's nothing I can do about it. Same here, 2, A. So one of the bits on that guy right there is stuck high. So I'm going to replace that guy, and we'll see a lot of life. I bet you it fixes the board. But I put all of these guys in my reader. None of these come out to punch out in MAME, so that's a little concerning. And you can see my color palette is totally goofed up. So I think all of these are bad. But one thing at a time. I'm going to replace this 367 up here. There's a couple more maybe that I can analyze. I'll throw this on it real quick and make sure, like, there's one right here, 367, and I think that's it. So I'll check that guy out, and then I'll replace this one and go from there, and then come back. Okay, so remember this guy right there was bad. We're replacing that one. It had a stuck bit. Now I moved it over to this guy, and I'm checking this guy out. And that one right here is 3E. And you can see it buffers a lot of these control signals coming through. 367 3E. And pins 1 and 15 are always grounded, so this is always enabled. And you got 367 there, 367 there. This is all the same 367. And right up here, these 2 control signals are coming through and being buffered by that 367. So that guy's doing some stuff. And you can see here, same thing. the top 2 bits of the 6 bits are stuck high. You got 0F and it's saying 3F, 0D, 3D. It's always outputting 3 something. No matter what this is, it's always outputting 3 something. See that? 0E, 3. You know, of those 6 bits. Okay, my question is, are bits 3 out to 4 and no, 2 out to 3 and 4 out to 5 being used? There's 4 out to 5. Right there's 4 out to 5, so that is being used, and then 2 out to 3 is right there. That's the high side. These 2 guys are the high side that I'm hooked up to. So yes, that is being used. And we'll take the logic probe here and probe 2 and 3. There's 2 out to 3, 4 out to 5. But see, this is the limitations of a logic probe. It tells you, yes, it's moving. You know, 2 out to 3 and 4 out to 5, 6 out to 7. Strange. But yeah, it tells you that things are moving, but this tells you if they're good or not, and that's clearly not good. So I got 2 367s to replace, this guy and that guy, and then we will move on from there. Okay, I replaced this guy and this guy, those 2 LS 367s, and you can see we are making progress. Color palette's still goofed up, but we are now somewhat there. We're still missing the Glass Joe and the Challenger over here, and you know, those guys right there are still not right. That's still not right, but like I said, we are getting there. And to be honest with you, that could be color palette ROMs. You know, that's a problem, because these things, I put them all in my reader and they were all bad. I mean, they all came up with nothing. They're not punch out ROMs. So I don't know. And then I read these come out as punch out, and I read a couple of the video sprite ROMs, and they come up as punch out ROMs. So it's really strange that every one of these is coming up to nothing. But yeah, so I don't know. That's a weird one. I wish I had another punch out board set here so that I could swap and compare these guys. I don't know. But we're definitely making some progress here. So yeah, there's something still wrong with this, because even if those palette ROMs are bad, there should be something blitting up here with the Challenger and Glass Joe. You know, there should be wrong colors or whatever, but there should still be image there. So there's still something going on with this board. So I'm going to have to just keep poking around, and I'll be back if I find something. Alright, I've been doing some testing on 244s, and they were all great. You can see the 244s up here. When it's enabled, they match. The inputs and the outputs, when it's enabled, will match. Those 244s were not an issue. So what I did out of a hunch, because these things are all wrong, right? This one, and this one are for the top monitor. So I've got these two guys lifted. This one's kind of in, but this one's lifted. This one's disconnected. And look at this. I know it looks totally messed up, but you can see the silhouette of the characters. They're there. The characters are there. They're just not being... See, you can see Hall of Fame now. See the little guy there. And then when the fighting is going on the bottom screen, you can see there's Glass Joe. There's the Challenger. They're there. The color's just not there. When in this area, these areas of the screen, it's got to be just writing out all 11 or FF to get complete white through here or something. I'm going to have to get new PROMs for that. I think that's where we're at. So this one's going to have to go on hold for a little bit. I'm going to order some 82S 131s. Burn them. And then come back. Okay, Jason informed me that he had these chips. And as you remember, all of these guys tested bad in my reader. They don't come up as punch-out ROMs. So I'm going to go ahead and put these in here that he got. I don't know where he got them, but he sent these. So we're going to pop those in the board and see what our screen looks like. Okay, I've gone ahead and swapped out those PROMs. There's the old ones. And check it out. Looking beautiful. So let's go ahead and switch over. I'm going to cut away really quick, and I'm going to switch over to the bottom monitor and check it out. But this looks beautiful. Well, here's the bottom monitor, and it does not look good at all. So I think we still have PROM issues. The bottom monitor, I believe, is this one, and this one, I think. So I'm going to pop out 8F. And I'm going to find the old 8F. Pop the old 8F in. I'm going to pop out 8E. Put the old 8E in. See what that does. And 7F. And here's old 7F. Yeah, it's still messed up. So we have a color select issue of sorts, I believe. This was way better than this before. Remember? Well, let me do a little bit of digging here and find out what's going on here. Okay, I put the newly sent to me PROMs back in the board because I know that these ones were bad. You know, these ones were bad. I know that for a fact. So I'm going to set them aside right over there. Those were the bad ones. I put these guys that he sent me, I put back in the board. The top monitor is great. Top monitor is good to go. That's right. Everything looks good on this monitor. That's all good. Oh, I see him flake a little bit. What's up with that? Okay. So we're going to have to start with the color outputs for the bottom monitor and kind of work our way back is what we're going to have to do. But I guess what I'll do is I'll find out exactly which one of these PROMs is the PROMs for the backboard. I'll put them in my reader. I'll make sure that they're good and go from there. If they're good, then we know that they're good and it's something else. So, alright, so we'll be back. Let me do that. I'm going to verify the PROMs for the top monitor and we'll start at the output and work back. Okay, weirdness. These three guys are the ones that I verified good as punch-out PROMs. I pulled those out, put in the bottom monitor PROMs that were in this board to begin with. Remember, they verified bad in my reader. And I put them back in, and we're back to this. It's not quite right. There's too much blue. But the funny thing is now if I take and I swap, I'll try to do this one-handed. Okay, now I'm on, almost on top monitor. Come on. Okay, here's the top monitor. The top monitor is good with the PROMs that he sent me. I am kind of suspecting to be honest with you, that I need 353s right here instead of 153s with these chips. I think one of these, I think the blue one for here might be bad. I think that these are reverse data chips, and I'm going to look at that, and I'm gonna see if that is the case, and see if the data in these guys, these three guys right here, are inverse the data in these guys, because I think that's what it is. But these guys up here are good. No, I don't have to mess with those, but I think these guys, these guys need to be the absolute inverse of these three guys, but I think one of them's bad. I think it's the blue one. So I think I'm going to pop the blue guy out. That is this guy right here. So that's 8F. 8F is the blue PROM for the bottom monitor. I think that guy might be bad. So I'm going to go ahead and, what did I say it was? 8F? 8F. I'm going to go ahead and pull that guy out and see what it looks like. I'll be right back. Okay, I just removed the blue chip, and you'll see what I'm getting. That's what it is, because this looks good minus blue. This is all just red and green. And you'll see as it plays through a little bit. I think I'm going to go ahead and reset the game, and by doing that I have to turn it off and then turn it back on. So I'm going to go ahead and do that. Turn it off, turn it back on. You'll see the splash screen. The background is now black. There's no blue haze behind it. And then this next screen where it says introducing Glass Joe or whatever, you remember it was blue most of the time. See, now there's no blue there. It's just that blue circuit's not right. So that's what it is. So we'll go ahead and look at that. I think it's just chip, to be honest. So let's do that. Let's look at these two chips, the blue PROM, and see if that data is supposed to just be inverse. Because I think that's what it is. Let's check that out. Okay, a little bit of an update of what I'm doing. First of all, I replaced these caps. I replaced the two transistors in the blue circuit just to see. It was a quick and easy thing to do to see if that was an issue. But it wasn't. I mean, they looked good. I looked at them with the scope and they looked good. I just figured, why not try it? I have the actual punch-out PROMs in the board right now, and I'm going to put 353s in the board. That's what the schematic calls for. And these PROM chips that were in this board, I don't know what they are, because they are not nowhere near the inverse data of the actual punch-out PROM chips. So I don't know what these guys right here are. There's another one. It's inside. It's in the house. But yeah, these guys right here, I don't know what they are. I figured they're probably maybe an inverse version of the actual punch-out PROMs, but they're not. It's not even close. So I really don't know what they're all about. But the actual verified good punch-out PROM chip set for the top monitor, these three guys. No, these three guys right here. Those are the actual punch-out PROMs, and you've seen how that fixed my top monitor. These are the bottom monitor red, green, and blue PROM chips. I'm figuring, I mean, these are good. These are actual punch-out verified PROMs. So what I'm going to do is I'm going to inverse the addressing to them with putting 353s in the board and see if that fixes my problem. I mean, this is a weird one. You get mix and match PROM chips for punch out, and those ones that were in this board, they don't verify to anything, and they're nowhere near the inverse of what's in the data that's in these chips. So I don't know what it's all about, to be honest with you. But I'm going to go ahead and pull and verify all of the software in this board set. All of the video ROMs, I'm going to verify them all to punch out. These will be all verified to punch out. And I'm putting 353s, which I do not have any 353s, so I have to order them. And then we'll pick back up with this one after I get these 353s, and hopefully that fixes this. Because I don't know what to do with these guys. Because I don't know what the data is supposed to be. I don't know if it's actually I mean, all 6 of them are bad. That's kind of fishy. So I really don't know. I'm trying to go to a known state. All punch out software 353s, which are in the schematic for. I mean, I know that 353s and 153s can be used, but that is, if you inverse the addressing to this, then you have to inverse the data in either the ROMs or the PROMs or whatever. That's why I want to check the ROMs for all of the video. It's messed up, but something weird's going on with this one. I'm just trying to get it to a known state. Anyway, I'm rambling on now, but that's what I'm going for. So I'll be back once I get the 353s to put in this board and go from there. Okay, I got my 353s in the mail, my eBay purchase. These guys right here, 74 LS 353. And it has fixed our color problem. So this thing was a complete hodgepodge. Number one, it had all bad ROMs, which was weird. All these were no good. These are the spare ones that the owner of the board sent me. So those are all in the board and they are good to go. This board had 153s in it, and these were switched. I had to switch these to 353s. What happened? You know what? I can't even say that. I don't know what happened. These PROMs, I believe, were all corrupted. But they were flipped, I believe. I believe that the data or the addressing was flipped in them to accommodate these being 153s. Well, these were corrupted, so they wouldn't work with 153s or 353s. So he sent me a spare set of pallet ROMs. They all verified to punch out, just regular. I put them in the board, and while the top monitor was fine, because the top monitor, it's addressed with these two 158s here. So the top monitor was fine, but the bottom monitor, the colors were all crazy. That was with 153s in the board. So I bought these 353s and popped them in these sockets in the board, and boom, now it works. Just absolutely crazy. But this one, I don't really even remember what was wrong with this, other than I'd have to go back through it, guys. I really can't remember. I work on too many boards. Like when I'm waiting on something for this one, I work on another one, you know. So I'd have to go back through the video to find out exactly what was wrong with this guy. But it is looking good now. I'm not seeing any glitching. I'm seeing no glitchiness. I do have to test the sound. So I will hook up my amplifier and go through some sound checks, and then we'll be able to wrap this one up. So I'll be right back. Okay, and we are ready to do our sound test. So we'll go ahead and do this. On chip at 2R, I'm going to ground pin 8. And then chip at 1R, I will ground pin 17, and that'll start the countdown. So here's pin 8 on 2R. maybe. Okay, and 17. And I'll switch the channels as needed.
Flash Joe! Fight!
I'm not very good at switching the channels, but you can see they both work. And that's going to do it. I don't have any controls hooked up. I don't know what they are, so. It's looking good, though. And top monitor. Very good. All right, guys. Appreciate everybody watching. This was a long one, I think. I got to be honest with you, though, I don't really remember what everything was wrong with this, but I'll go back through and watch the video and kind of go back through everything that was wrong with it. I think it started out with a busted crystal. It did. I can tell the crystal was soldered on there. And it looks like all of the DMA counters were replaced. So there's quite a bit of work that was done to this guy, I guess. Looks like I replaced the CPU socket. Yeah. Alrighty. Well, thanks a lot for watching, everybody. Appreciate it. If you liked it, give me a like. Subscribe if you haven't. And we will see you on the next repair. See you guys.